Here is the text punctuated. The Andromeda cosmic system was the world that uncovered the way that the universe and creation itself didn't spin around us. It was demonstrated that the smooth way isn't the main cosmic system on the planet. What's more, that we may very well be a bit in the more prominent universe. Generally, over the past century, we've really gained some significant knowledge about Andromeda, yet the vast majority of the data has been from Earth. Now that we approach instruments like the James Webb Space Telescope, things are a lot different. It turns out the Andromeda cosmic system isn't what we thought it was. History of the smooth way data from the James Webb Telescope has stunned the whole industry. Go along with us as we bring you every one of the subtleties on the reality with regards to the Andromeda universe and the stunning truth about it that we didn't see coming. For a whole century, a little more than 100 years prior, the smooth way was generally thought of as a band of weak, wispy, whitish lights extending across the night sky. This insight was impacted by the restricted innovation of the time, which kept cosmologists from knowing individual stars inside the smooth way. Individuals held different convictions about the smooth way, frequently connecting it with the focal point of all creation, where the divine and earthbound circles met. Galileo Galilei, an Italian space expert, was, as a matter of fact, the person who reformed our comprehension of the smooth way. In the mid-17th century, utilizing his recently created telescope, he made weighty observations that tested the predominant Aristotelian cosmology. He found that the smooth way was not only a diffused light band but an enormous assortment of individual stars, planets, and other heavenly items. The smooth way universe, the closest world to us, is the Andromeda world, and we think there are around 100 billion systems in the apparent universe. So, in all honesty, that implies we can really count the number of stars in the noticeable universe. Through his observations, he illustrated that the smooth way was not at the center of the universe as recently accepted, but rather an immense span of stars dispersed all through space. In 1750, English space expert Thomas Wright proposed another speculation in his work, an original hypothesis or new speculation of the universe. According to Wright's hypothesis, the smooth way was not an irregular dissemination of stars in space but a totally flat layer of stars. In addition, he likewise proposed that a part of this tremendous design was our own planetary group. While Wright's theory was a step forward in figuring out the construction of the smooth way, it was still restricted by the perception innovation accessible at that time. They generally still trusted that the smooth way was all there was to it, and considering the constraints, that was to be expected. Yet, cosmology made major jumps by the mid-1800s, and by the mid-1900s, things were changing quickly. In the 1920s, Edwin Hubble, an American cosmologist, made a groundbreaking revelation utilizing the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble noticed far-off nebulae beyond the smooth way. Through the perception and investigation of these articles, he showed that they weren't part of the smooth way. Yet, in truth, were completely separate cosmic systems, each containing billions of stars. One of the nearest of these worlds was the Andromeda universe, otherwise called M31. It has a rich history of perceptions that goes back hundreds of years. One of the earliest known records of this divine item can be traced back to the 10th century, when the Persian stargazer Abd al-Rahman al-Sufi described it as a little cloud in star outlines from that period. It was marked as the little cloud, which had to do with the way that when you inspect it from Earth, it seems like it has a faint cloud surrounding it. The meaning of these perceptions lies in the way that al-Sufi had the option to recognize this far-off infinite substance without the assistance of adaptive instruments, depending entirely on his sharp visual perception and observations. He was able to do that since Andromeda is one of the only systems in the universe that you can see from Earth's surface without requiring any exceptional instruments. All you truly need is to know precisely where to look, and you'll see it not too far off in the open sky. Sure, you can't go into a lot of insight regarding the historical backdrop of Andromeda yet. You can still see that something other than the standard stars is there. That is the reason it was only after 1612 that a more definite portrayal of the Andromeda system, in light of adaptive perceptions, was given by Simon Marius. His work turned out to be what laid the establishment for future cosmologists to concentrate on this enormous astronomical construction. Later, in 1764, the famous French space expert Charles Messier inventoried the Andromeda universe as M31 in his notable Messier Index, erroneously ascribing its disclosure to Simon Marius, ignorant about al-Sufi's prior work. However, that doesn't imply that he didn't have a significant hand in making Andromeda famous. For nearly 100 years after this, stargazers all over the world were attempting to comprehend increasingly more about this puzzling world, each adding to the last one's discoveries. A critical jump in understanding the nature of the Andromeda world happened in 1864, when the English space expert William Huggins made a notable observation. He concentrated on the range of Andromeda and saw that it was not quite the same as that of an ordinary vaporous cloud. That prepared for the world to get to truly know Andromeda for what it truly is. And while it's a great deal, the Andromeda world has a mass assessed to be somewhere in the range of 1 and 2 trillion times that of our Sun. It's a gigantic, inestimable structure that simply ends up living relatively near us in the tremendousness of space. In all the exploration directed as of not long ago, researchers trust that Andromeda is around 10 billion years of age, making it very old in astronomical terms. Its age indicates a long and many-sided history of development and advancement. One of the captivating parts of Andromeda's beginning is the speculation that it came into being through the converging of a few more modest proto-worlds. This suggests that over billions of years, more modest cosmic elements slowly came together under the power of gravity to structure the grand Andromeda universe we see today. Such cosmic consolidations are normal events in the universe, molding the development and design of universes. Yet, everything occurs at such a leisurely pace that you can't actually witness it until major progress has been made. For quite a while, cosmologists thought Andromeda was altogether more gigantic than our own smoothway world. From an objective point of view, a misstep like this could undoubtedly be made in light of the fact that we're in our own cosmic system, and seeing Andromeda from Earth makes things look so enormous that you'd easily feel that it's absolutely impossible that anything would be able to indeed even come near its size. Yet that is not the case. Late Andromeda's dynamic cosmic core research has brought about a reassessment of these convictions. New discoveries have driven researchers to somewhat lessen their gauge of Andromeda's mass, while at the same time expanding the mass credited to our smoothway. The Andromeda universe's actual aspects, however, are what cosmologists absolutely settle on. It's known to extend farther than our own smoothway, with a great width of about 220,000 light-years. Andromeda outperforms the smoothway's assessed measurement of about 100,000 to 175,000 light-years. This immense size makes Andromeda a truly critical infinite substance, assuming control over a huge area in space. This reconsidered viewpoint likewise features the intricacies and difficulties of precisely estimating the mass of universes. Worlds are monstrous frameworks, and their mass is unpredictably connected to the appropriation and developments of stars, gas, residue, and dull matter inside them. Sticking these qualities exactly is a requesting task that requires complex observational procedures and careful examination. So it couldn't have possibly been finished during the 1700s or even during the 1800s. This sort of information required current devices, which is the reason the truth is simply becoming exposed at this point. Despite the fact that by a long shot one of the most captivating highlights of the Andromeda world is its dynamic cosmic core, AGN. The dynamic cosmic core, prominently known as AGN, is a profoundly vigorous district at the focal point of a cosmic system. It is described by serious discharges across various frequencies, from radio waves to X-rays. AGNs are fueled by the presence of a supermassive dark opening at the core of the universe. These very gigantic dark openings are unbelievably thick locales in space where a gigantic measure of mass is concentrated inside a tiny volume. At the point when stargazers notice the dynamic cosmic core utilizing progressed telescopes like the Hubble Space Telescope, they notice an extremely fascinating peculiarity. The AGN seems to have two marks of fixation, meaning there are two particular locales where light and different types of radiation are exuding more strongly than in the encompassing regions. The more brilliant fixation is the second mark of center, which is simply somewhat off the genuine cosmic focus. Inside this region lies the supermassive dark opening. The mass of this dark opening has been assessed to be between 1.1 to 2.3 million times that of our Sun, which would not joke about this weighing around 110 to 230 million times as much as our Sun. Very enormous dark openings are accepted to be normal in the focuses of cosmic systems, including our own smoothway. Thus, they play a significant job in the development and elements of cosmic systems. When gas and stars get excessively near, a supermassive dark opening, it frames a growth plate around it. This circle of twirling material warms up and discharges extraordinary radiation across various frequencies, which is the reason the AGN is profoundly glowing. At the point when cosmologists notice the dynamic cosmic core of the Andromeda world, they notice a more splendid mark of fixation close to the focal supermassive dark opening. This element is a consequence of the extraordinary gravitational communications between the dark opening and the stars in its area. In the heart of the Andromeda universe, the supermassive dark opening applies a massively strong gravitational draw on encompassing stars. As these stars circle around the dark opening, they follow curved ways, like planets circling the Sun in our nearby planetary group. This unique gravitational dance between stars and the focal dark opening makes a profoundly vigorous climate that transmits strongly across the electromagnetic range. The investigation of Andromeda's dynamic cosmic core gives vital bits of knowledge into the physical science of very huge dark openings and their effect on cosmic advancement. These peculiarities are fundamental for figuring out the arrangement, development, and elements of universes all through the universe. Andromeda's AGN fills in as a close-by research facility for cosmologists to investigate the complex cycles that deeply impact the way of behaving of systems over enormous timescales. Past its dynamic core, Andromeda's huge scope and complex design keep on catching the interest of stargazers and analysts around the world. Its sheer size and nearness make it a noticeable subject of study, offering important similar experiences into the smooth way and different worlds. With progressing headways in observational innovation and hypothetical models, researchers are ready to reveal even more about Andromeda's secrets, shedding light on major inquiries about the universe's beginnings and development. As cosmologists proceed to unwind the mysteries of Andromeda, they not just develop how we might interpret our grandiose area, yet additionally upgrade our viewpoint of the universe's tremendous and different scenes. Andromeda remains as a demonstration of the persistent quest for information and disclosure, displaying the significant excellence and intricacy of the universe that encompasses us.